Hi, I'm Bryan Litz with Applied Ballistics. Today I want to take you through building a gun profile and getting set up to shoot 1,000 yards with AB Quantum. Okay, first thing we're going to do is get on target at 100 yards and get a good 100-yard zero and get a muzzle velocity with the Garmin chronograph. And with those things, we're going to continue on to build a gun profile. I'll show you how to do that. And then we're just going to immediately go to 1,000 yards. We're not going to mess around at any range in between. We're just looking at how accurate the fire solution is at 1,000 yards. So clearly it'll be that accurate or more at closer ranges. So, all right, first thing, we're going to get our 100-yard zero and velocities. This is a 284 Winchester. We're shooting 180 grain quarter hybrids, a 1-in-7 twist barrel, 24-inch long. It's really, the gun isn't the point here, but this is one of our workhorse guns that we use in the lab. We configure it with different barrels all the time. So today, this is a 284 Winchester, and we're shooting 180 grain hybrids, and we're going to see how well we can predict where they're going to hit at 1,000 yards. Okay, that's all the more shooting I'm going to do at 100 yards. The gun started with just a bore sight, had to move it about 1.5 inches to get it zeroed. So from those 5 shots, I'm going to take that average velocity. We're going to build a gun profile and we're going to see what we can do at 1,000. Okay, so we're starting with a blank user gun here. I'm going to come into here. I'm going to call this, I'm just going to call it 284 for today. I'm going to build a gun profile using the Applied Ballistics custom drag curve for a 180 target hybrid. Okay. It's got our length in there. Now our average muzzle velocity from those 5 shots, it's not a very large sample, but the average was 2630. Our twist rate is 1 in 8. The sight height on this rifle as configured is 2.7. 1 in 8. Twist rate. It might be a 1 in 7, but that shouldn't matter much. Okay, so now we've got that gun profile built. I didn't configure a reticle in there because I'm not using a reticle hold. I'm going to use the scope to dial. Okay, let's come over here to the shoot tab. And we're in the HUD. Our target is actually at 993 from our exact spot right here. For our environment, I'm going to swing the Kestrel around here and get good environmentals. Now, one thing that I'm eager to do on this trip to find out is I'm going to measure the environmentals with a Kestrel and put them in, and that's what we'll base the fire solution on. But then, after we go through everything, I want to see if, rather than input what the Kestrel said, if we collect the atmospherics from like the satellite signal, like you can do right within Quantum, how different those conditions are and how much that would affect our dope. Okay, so we're at 77 degrees, 57%, and 28.87. Okay, and I believe that's going to get our latitude pretty good. Okay, let's see what we have to put in for our target. We have no inclination. Our azimuth is, let's see, we're facing kind of north. Okay, so there's our azimuth, 245, no inclination, target isn't moving. For wind, let's see, looks like a fishtailing headwind, but seems to be staying on the right side, 11 to 2 o'clock. So I'll give it a 1 o'clock, 5 mile an hour. The real point here isn't to get the wind call right, we're mostly looking for elevation. See how accurately we predict our elevation. So right now it's calling for 8.7. I like the output rounded. I think that's up here somewhere. Rounded, there we go. There, now it's, okay, 8.7. Let's see, we got our atmosphere in there. We have the range. We can't do any ballistic calibration yet. We haven't even shot. Okay. I didn't turrets on this scope after I zeroed at 100 yards, so I'm just going to add the 8.7 onto whatever it reads here, which is 1.9. So I'm going to do that math. Okay, so we've got our 8.7 mils of elevation dialed, and I think we wanted 2/10, right? Not very much. Okay, I'm gonna realign the chronograph with a 1,000-yard target, because we'll compare the muzzle velocity. Like, suppose that 5-shot sample at 100 yards wasn't our real average, and we shoot this 1,000-yard target, and maybe the average is 10 feet per second faster, and we'd hit higher, and we'd think, oh, the solver was off. Well, it would be off only because we used the muzzle velocity sample from 100 yards. So I'm going to get a muzzle velocity sample on the 1,000-yard target too, so we know what our actual muzzle velocity was for that. Looks like the wind totally let off, so I'm going to come back. Okay, so that group seemed to center up really well vertically. We should have a picture of it in the video here. Our average velocity was 2630, which is exactly, yeah, that's exactly what our profile was based on. So that was a really good example. Luckily, our average velocity for those 10 shots at 1,000 was exactly the same as the velocity of the 5 shots we used to zero at 100. So I mean, we took 5 shots at 100 yards with this rifle that was just put together and just had a scope bore sighted on a quick detach rail. Within 5 shots, we had a 0 and a muzzle velocity. And with that 0 and muzzle velocity and scope height, that is also a thing you have to measure. We built a gun profile in AB Quantum, and we entered the target parameters, the atmospheric parameters, and we put 10 shots into a group that was centered vertically. Okay, windage is another story. Windage is always going to be a matter of judgment. The ballistic solver will give you an accurate wind correction if you tell it the accurate wind in the field, which is the hard part. That last string of fire that we did was, we calculated that fire solution using atmospherics from the Kestrel. Okay, now I'm going to see how much the atmospherics change when we pull it from the phone signal and how much that changes our elevations. So I'm going to write it down first. We had 77 degrees, 57%, and 28.87 inches. Okay, now when I get those from the phone input, they all change a little bit. Okay, 77 changed to 72, 57% changed to 71%, and 28.87 changed to 28.85. Okay, and our fire solution was 8.7 and it's still 8.7. So that's an interesting example that says, at least for this case, the atmospherics that you can pull from Quantum directly gave you the exact same elevation as measuring directly with a Kestrel. That just says for this combination of ballistic performance at this range, that error wasn't enough to hurt your fire solution. That may not always be the case. But we're here mostly to show the predictability of drop with ballistic software, and that was a pretty good example. 5 shots at 100, and then we put 10 shots at 1,000 centered on the aim point. If you're on the range and find yourself needing a fire solution at long range, check out AB Quantum. It's a pretty easy app to use, even though it does have a lot of advanced features. So you can check out other videos on this channel to learn more about those features and how to use them. But this video is just meant for the basics, 100-yard work, to getting a solution at long range.